All right. Welcome everyone who just arrived. It's great to see so many faces. Thank you all for being here. Our keynote speaker, Ben Orlin, is going to be speaking in just a moment. Ben is the author of Math with Bad Drawings, and that book has sold remarkable copies, over 100,000 copies worldwide. His other math books, which I hope that we will all explore at some point. He's had his work appear in the Atlantic, Popular Science, Los Angeles Times. He's taught middle schoolers and high schoolers and currently teaches at St. Paul College. We are delighted and privileged to have him here tonight to speak to us. So Ben, please.
Yeah. Thanks so much, Neil, for having me, and thanks everybody for being here. I'm excited because we'll get to play games for the next hour, which I like to do. Although I should say I don't love to play games myself. What I love to do is watch other people play games. I go, oh, I shouldn't have done that. That's really my dream. Really, thank you for having me here. Just walk around doing that. Yeah, so as Neil mentioned, I do books. This is improbably what I do for a living. Coming out of college, I got my bachelor's degrees in math, and I decided I wanted to be a teacher, and the dream was sort of somehow maybe down the road I could fuse teaching and writing. And it took me like weirdly 3 or 4 years before it was like a friend of a friend who was like, why don't you write about math? I was like trying to write other stuff, trying to write comedy, I was trying to write poetry. It's like, you write, why don't you just write jokes about math? That's what you do all day. You could do that. That's clever. Never would have thought of that myself. So anyway, that's now what I do for a living. Yeah, anyway, we'll be talking mostly today, the games from that yellow book. This is a big, really surprisingly heavy. I don't carry it around anymore because I've got to make this back last for a few more decades, and then really destroys it. But the book began, this is a long time ago now, 2000, well, actually I'm not going to say how long ago, it was a long time ago. And I was at a math department picnic. My wife was in grad school at the time. And I show up a little late at this picnic, and the math students are all gathered around the table. I'm like, oh, what's going on? What they proving? Like a picnic? I don't know. Like, what they're playing a game? Are they playing Go? Are they playing chess? Like, no, they're playing tic-tac-toe. Mathematicians, come on. Tic-tac-toe, like you're better than that. Raise your hand if you've seen this game before. Okay, all right. Well, we don't need to go over the rules. We don't belabor that. They were playing Ultimate Tic-Tac-Toe, which was at the time I think not yet known as Ultimate Tic-Tac-Toe. It picked up that name when I showed it to my high school students, and then in the way that high school students do, they just all spontaneously started calling it Ultimate Tic-Tac-Toe. That was just immediate consensus. That was what they were going to call it, and so that's now what it's called. Anyway, is anyone in the room who has not seen this game? Not to put you on the spot. Oh, excited. Okay, great. Well, you're going to meet a wonderful game today. It's a tic-tac-toe board made of tic-tac-toe boards. And as I was watching it play, I was like, doesn't seem like much of a game. And in particular, people were making weird moves. They were, imagine the first move of the game there. I walked up halfway through a game, and they were like missing 3 in a row. I was like, oh my gosh, this PhD has fried your brain. You're sitting here playing tic-tac-toe, missing 3 in a row. It's like, what does category theory do to the mind? And then it took me a little while. I probably don't even realize it myself. Someone explained to me where you go determines the board your opponent plays on. So first move of the game, you can go anywhere. They go in the upper right corner of that little board. Now their opponent has to go in the upper right board. And then, okay, their opponent goes there. Okay, O takes bottom center. Now where does X have to go? Bottom center board. And so it goes on like this, right? You gotta go on that board, and X goes there, sending O to the bottom left, and then O goes there, sending X to the bottom right, and then X takes the middle. Now O finally gets to go on that center board. And so it's a simple rule, right? It takes a minute to figure it out, but it weaves this wonderful tension into the game, because a good move, right? Like you like the center in tic-tac-toe, but a good move on the small board means you're sending your opponent to a good board. And similarly, if you want to keep your opponent contained to a bad board, you gotta go in a bad spot yourself. Anyway, so just that rule itself, this is some of my favorite moments in math, or when there's some kind of intrinsic tension between 2 constraints or 2 aspects of what you're trying to maximize. Anyway, I thought that was a cool game. Right now on Wikipedia, it's Ultimate Tic-Tac-Toe, and down in the references here, you see there at reference number 3. It was like a fun moment. I had started a blog a few months before, and then suddenly this game like goes viral. It's on Reddit, it's on Hacker News, it's everywhere. It was a very weird moment for my little blog, and back in, well, now you see 2013, long time ago. So, right, and there's a whole little mini academic literature out there on this game now. So I showed this to students, and there was a teaching high school at the time. And I think if you asked me then, like, okay, why do math games matter, right? Like, oh, it's fun, it's cool. I would have been like, I don't think it matters that much. I'd rather like, it's fun to play this with my students, but then I want to get back to doing the real math that we're doing. I want to help them learn algebra. I want to help them learn calculus. I want to get back to the real stuff. And for a while, that was my answer. I like games I thought were fun, but like kind of a distraction from the real work of math. And I've changed that answer. Yeah, I don't feel that way anymore. I feel games, there's something like what's great about mathematics is it taps into something that humans enjoy. There's like some set of instincts and attractions that we feel, and math taps into that. And games do the same thing, and there's some weird connection there. I don't fully understand yet. So when I wrote this in my first book, I sort of used it as a metaphor where I say math as people experience it in school is often sort of like playing regular tic-tac-toe. It's like you figure it out by age 8 and then it's really repetitive after that. Or you don't figure it out and it's still really repetitive after that. And what I want math to feel like is more like ultimate tic-tac-toe, more like a nested series of games. Yeah, in math, I don't know quite what the big board and the little boards are in math, but I feel like that's true. The little board is this problem you're working on, and the big board is this larger picture that you're developing. And another thing, this just came across in the last year. Has anybody read this book? Oh, it's a fabulous, I don't know if you thought that. It's a great novel, I think. It's about John von Neumann, the fictionalized account of his life. And so there's this quote attributed to someone who knew John von Neumann, I think just written by the novelist. But for me, like crystallizing when I think about games. So it's right. He once told me that just as, this is von Neumann in theory, once told me that just as wild animals play when they are young in preparation for lethal circumstances arising later in their lives, mathematics may be, to a large extent, nothing but a strange and wonderful collection of games. An enterprise whose real purpose, beyond anyone's stated outright, is to slowly work changes in the individual and collective human psyche as a way to prepare us for a future that nobody can imagine. Which I love because it makes games sound so sinister. So suddenly there's this darkness to play. And maybe that was there all along. There is something spooky about play. Anyway, but let's play a game. So why do math games matter? I think von Neumann maybe has it right there, or fictional von Neumann, that like they change the way we think. So here's a game I like. This one's called Pig. You guys want to play Pig? Do not know why this game is called Pig. It's just that is what it's called. In a minute, you're going to stand up. Here's how the game works. Everybody starts standing up, but not yet. Good. Not standing up yet. I appreciate that. When I've done this with students, it's like, all right, stand up. They're out the door. So I'm going to repeatedly roll a 6-sided die. I've actually already done this. You'll have to take my word. I've like built it into the slides. So you have to take my word that these were authentic rolls of a 6-sided die. They really were. I promise. And then when we roll that die, its value is added to the current prize. We're just keeping a running total. So first roll is a 5, the running total is 5. Next one is a 4, running total is 9. At any moment, you may sit down, and that locks in your score for the round. If you sit down when it's 9, you have scored 9 points for that round. None of the later rolls affect your score in any way. You might be thinking, that sounds like a bad strategy to sit down. I will remain standing. But if a 1 comes up, the round ends, everyone who's still standing is wiped out, and scores 0 for the round. So if you stay standing permanently, you will eventually, at some point with probability 1, a 1 will come up and you will be wiped out. So you have to sit down at some point. And the question is when? We'll play 5 rounds, or I think it says 5 here. We're not going to play 5, too many. 3, we'll play 3 rounds. That sound good? And highest total across those 3 rounds wins. We will trust you to keep score yourself. If you say something outlandish, like, oh, I scored 900 points, we can factor it. But also, we'll let you have it. You probably, if you're going to lie in that game, you need to. So anyway, quick summary there. These 2 through 6, those are good for you. You're a happy pig. 1, you're a sad pig. Questions? Ready to play? Stand up. All right, 3 rounds. Same dice will appear on each screen. So if you can't see that screen, you can look at that screen. First round, the first roll is a 4. Love it. Sitting down already. Taking those 4. Okay. Anybody? Okay. All right, we got a call. Okay. We got 2 people sitting. Yeah. Yeah, when I play this with my students at the community college where I teach, they never sit down at the first die. They believe in taking risks. 3, we're at 7. 7, okay, we got a couple folks sitting down. Most of the room still standing, okay. A 2, we're at 9. That's great. Everybody's got their line. 7 wasn't enough for you, but 9, you're like, oh yeah, 9. 9's great, love 9.
No, they're just watching. That's it.
There you go. That's right, I forgot, these are linear dice. All right, we got like half the room still standing, and the next one, slide advancer. Oh, there we go, okay. 5. So we're at 14. Everybody like to buy back into the market? No, yeah, I can't. Yeah. Once you sell, you're out of the market. All right, we got a dozen more still standing. Let's see. Oh, there we go. Oh, sorry. So if you sat down on 14, great job. You saw the motor. You did well. Round 2, stand up. All right, round 2, first roll is 6. All right, we got a couple. Yeah. Are you folks who scored 0 last time? Sometimes that happens. You know, you score 0 the first round. It's like I need something. I need something for the page. Okay. Sit down. Third round, and then yeah, I'm pretty sure I don't put 3 rounds in the slides. Just yeah, the 5 is 5. Yeah. Too many. Okay. Third round. First one is a 3. Anyone want their 3 points? No, you're all willing to let it rip. Another 3. That's bad now. 6 is your number. You're just out at 6. That's fair. That's like yeah. It's me on Friday night. I'm just sleep at 6. Another 6. 12. 10 total. 4. So we're at a put a running total in the corner red. No, wait, no, I'm with that. 16. Yeah, 16. That's right.
It's not like you're gonna touch people are good and bad.
At least 12. 16. All right, we still have these numbers. 22. All right. Oh, this table. It's out. I guess the table. 22. 27. All right, take your 27. Jot that down. Jot that in. 27. All right, we got 33. Take it. All right. We still have. I've actually been doing good running scores for me. I think that's 36. We're 36. Yeah. Looks like 36. All right, sitting down with 36. We've got okay. We've got 3 still standing. 39. You can take your 39. All right.
Oh.
45.
Oh, wait.
So yeah, 45 was the right time to sit down.
I got 45 points.
All right, well, again, check with those around, see who won in your immediate vicinity. Questions or thoughts about that game? Things you want to share from your experience, triumphing or being. What was the high score in the room? We had right 45. You know, beat 45. You would have had. Oh, what did you have?
48.
48. Oh, 48. It's gonna be hard to beat. All right, round of applause for 48. Yeah, you have to share about how you got such a huge score?
Well, I figured, I got 9 and 0 on the first 2 runs. So I figured there's still people who's standing who got 14 on the first round and maybe sat down on the first round and the second round. So
Right.
either I sit down and lose or I stand up and.
Right, got
Right, right.
yeah.
You take
Right.
right.
Right, one thing, well, so one thing I like about this game, right, it's a simple calculation for if you're playing a million rounds, how do you maximize your expected value? That's a pretty straightforward calculation. What do you do if you want to win in a room full of people? That is a much harder calculation because presumably not everybody's going to be doing the expected value maximizing thing. Some people are going to be crazy. They're going to be just like standing up until all hours of the night, just letting it ride, waiting for that one big round. And so, you know, who out there is pursuing a high variance strategy, who's going low variance, it becomes, you know, just even though it's just one 6-sided die repeatedly on a board, but it gives a lot of, yeah, no, it pits you against the other minds around you in a way that I like. So why math games matter? This is a slightly separate reason, but the thing I like this for the students I teach, who mostly you guys are all very sophisticated mathematicians. Some of the students I teach are like that. A lot of them are sort of coming a little reluctantly into the math classroom. And in particular, something you will notice about human beings, if you've ever interacted with any, not very good at probabilistic thinking. They really think they know what's going to happen or that they've found a pattern when it's like, no, it's just 1 through 6. It's just random every time. And part of the reason is that the world is this complex, messy space, and you can't develop intuitions about probability, I think, until you see a very simplified world. Something like just 6-sided die over and over, and start to build some experiences, this kind of, you know, randomness in a bottle, where you can start to learn, well, what is the nature of randomness? One thing that this game teaches you is to deal with regret. Because the chances are, when you sit down, 5 in 6 chance, that was not the perfect time to sit down. Right? 1 in 6 chance, you nailed it. 5 in 6 chance, you did not. And so most rounds, you are left with a little bit of regret. Could have gotten 45. Or you sat down with 12. You're like, oh, I could have gotten way more than that. But whatever your strategy is, you have to live with these things. Expected value maximizing, by the way, is much higher than most people are going. It's like you sit down at like 25 or so. So there's some risk-averse part of us that we should be aware of and ready to overcome. Okay, ready for another game? This one, I love this game. This is I learned this from Douglas Hofstadter, who author of Gödel and Bach. He wrote about another one of his books, and this is a game he developed with 2 friends. So mediocrity, and the goal with this game is to not be that good at it. That is how you're going to work. So you'll play with a trio of people around you. We'll divide them up. Let's show you the rules. So the game's with 3 players. You can play with any odd number, but we'll go with 3. Everybody picks a number from 0 to 10. You can do it like kind of rock, paper, scissors style. So, you know, 1, 2, 3, go. And you hold up 7, you hold up nothing, you hold up 10, whatever you want. The numbers are revealed, and then the winner is whoever picks the medium. So you don't want to, 10 is not going to score you points, 0 is not going to score you points, whatever. So say the middle, what is it? Say it's 1, 3, 8. Person who held up 3, they score 3 points. Or if it's, 6, 7, 9, person who held up 7 scores 7 points. Again, you might be thinking this is, one detail. This is a slightly anarchy raising rule that I like to use. If it's a tie, if it's 2, 2, 7 or something, I like to let the 7 choose who gets the points. Just to add a little anarchy to your experience. Again, this might sound like kind of a boring game, so aren't we all going to throw a lot of 5s and 6s? But no, you're not, because then you'd be too good at the game. You don't want to be too good at the game. You play 5 rounds, and at the end, you want the median score. So you don't want to win every round. That would make you terrible at mediocrity. You're really good at mediocrity. That's not mediocre. That's terrible. That's terrible at mediocrity. You don't want to win no rounds. That's also bad. In the middle. That'd be okay. Questions about how to play? I think I have a sample round. So that's you if you're good. If you're mediocre. They're gonna sample round here.
Wait a second. Those numbers are between 1 through 10.
They have a lot of bigger. Yeah. I want to. I think it's working together. Yeah, well, congratulations. Or condolences to the winners. Not the game where you want to be trying to. Anyway, and of course, the championship level version of this is if you really want to kill some time, you play what, 3 or 5 games, let's say 5 games. Not every audience sees where that's going. Yeah, and he gets 4 wins there. So this one, right, gives me again kind of like a different answer. What's the kind of thinking that we're learning in this game, or what is this training upon us? Hopefully not to export mediocrity to all the other parts of our life. But I think what it's teaching me anyway is that games, and similar to math, yeah, a lot of branches of math, they let us explore some kind of space, sometimes a very ill-defined space of logical possibilities, and kind of find what's around the corner that you might not have anticipated. So I've played a lot of games in my life. Most of them you're trying to get the most points. A few of them you're trying to get the least points. I did golf once. It didn't go well. It was just sort of like I was playing it to get the most points. But I never played a game where you're trying to get the middle number of points. That is this thing right there in logical space. It's right there waiting for us. But never seen a game like that, never tried playing it. And in fact, once you make that the target, like that is the game itself. It's just trying to get the middle number of points. You could use this as a mechanic in some more complex game, but just that thing itself is such a weird mechanism for a game that I don't know, I find some delight just in exploring that. Here's another one, Roll Call. This one's a 2-player game. Someone just came up with a better name for this recently. It was, so some students that I spoke with very early on called it Bossy Tic-Tac-Toe, which I like. It's a tic-tac-toe variant. That's someone recently suggested Tic-Tac-Faux, which is another good name for this. So here's the idea. I call it row call because you are calling out which row or column you want to be in. So here's X. You play on a 4x4. You only need 3 in a row, so you don't need 4 in a row. I would say in a row, I mean consecutively, right? Diagonals count. X doesn't get to place X's mark. X points to the top row and says, I want to go there. And then O is the one who decides where X goes. So presumably X wanted a corner. X is not getting a corner. O is going to put X in one of those weird ones. Then O says, I'd like, O can pick again a column or a row, either way. And then X decides where O's mark will go. So presumably O wanted one of the centers, O does not get a center. X puts O at the edge. So this was sort of vaguely inspired by, it's sort of very general thoughts about game theory, right? The minimax theorem is sort of one of the, right, that sort of foundational theorem in game theory. And in general, you need to think about the maximizing your worst case scenario, right? And this game is very much built around that. You're going to get your worst case scenario if your opponent is good. So how do you make the worst case scenario as beneficial to you as you can? One way to simplify it, so you're not saying like 3rd column and then your opponent doesn't remember what a column is or what a row is. I like to write your pick at the side of the board, and then you just say the letter. So if I want to go in the top row, I say P, or if I want to go in the 3rd column, I say U, and then my opponent places the mark. And again, you just need 3. So to demo, right, like X, 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 that's a win, but X, X, blank, and X, that is not a win. Right? You need 3 directs in a row.
Can you do diagonals?
Yeah, diagonals count. You can even do the non-major diagonals. So X, 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 that's a win. Questions? Oh, but you can't, if the question was, so you can win along a diagonal, but you can't specify a diagonal. You can't say, I want my mark to go somewhere on this diagonal. Otherwise, you'd be like, I would like my mark to go somewhere on this diagonal. Other questions about how to play? Okay, so this one just one opponent, and if you find yourself the odd person out, then you can try to rotate quickly. It's a short game. Share insight. You got Oh, yeah. Alright. Thank you for playing that one. Any comments? Oh, actually, people in the room here. Let me take the three names under consideration for this game. We've got roll call, we've got tic-tac-toe and boxy tic-tac-toe. Think what's your favorite among those three? Is it roll call? Raise your hand for roll call. Oh, well, some support. Okay. Boxy tic-tac-toe. Okay, and tic-tac-toe. Okay, that was deeply uninformative. Thank you. I mean, I shouldn't say that. It was informative. Just to give me the idea I want. The answers those are all they're all fine. So yeah, this one. Any thoughts, questions on that one? Anyone share? Yeah, one thing. I don't think this is the thought I put on the slide. Yeah. So one thing, especially for students going through their math education, really at any level, a lot of what learning to think mathematically is learning to really attend to edge cases. One of the things I like saying for my students is like, if I ask for an example of something, some object or some, data set that fits a description, and they're like, well, the data set 0, 0, 0, 0. I'm like, yes, you're thinking like a mathematician now. Because always the first thing you check is like, okay, what if it's 0? What if it's 1, right? Check the trivial case. And so mathematicians, to think mathematically is often to get used to just like looking for those edge cases. In this game, actually kind of forces that sort of thinking on people, especially people who aren't accustomed to it. I've seen people play this game, and the first time they play, they make really, really ridiculous moves because they're just not used to thinking about like, oh, I thought they would put me there. Why'd you think that? They're trying to make you lose. The other thing, the thought of this game, I really like it at this size. I've tried it at other sizes. It just doesn't scale well. So some games you can scale them, right? They work at different sizes. You can play mini Go, right? Or you can play big Go on the normal board. This one does not scale well because if you play on you need 5 in a row on a 7x7 or something. 7x7 is like 50 spaces almost. The first 20 moves of the game are really boring. I'll put you over on the edge. They're gonna put you over on the edge. Yeah, sorry. Oh, wait, so what would you, yeah, I guess, right, you could do it the same way. You could specify a row or a column. Oh, no. Yeah, no, that's a good matchup. I like that. Yeah, I've seen there was someone who coded up a version of Ultimate Tic-Tac-Toe, which was like connect 4, but connects 3. So you sort of like drop it and it goes down to the bottom. And that one I thought was fun, but I haven't thought about doing Ultimate Tic-Tac-Toe. So okay, well, that's sometime in the next week I'm losing hours. All right, so next game. This one's a quick, simple one. It's called Black Hole. And this one comes from this guy I love, Walter Joris, who I think Belgium, I think is where he lives. He's got a beard like one of these beards, just like bigger than a child's body. And he just comes up with so many games. So this one's a simple one, and it has researching my games book, I read a lot of Winning Ways for Mathematical Plays, which you may be familiar with. Sort of a classic, it's a really cool book by Conway and Berlekamp and Guy are the authors. And so it's about combinatorial game theory. And they developed some really powerful theorems and frameworks for thinking about combinatorial games. One of the things I don't love about the games they study is very few of them work as games. Like they work beautifully as game-like mathematical objects, but they often have the property that like you don't really know what's going on until suddenly it's the last move of the game. This one has a little bit that quality, but dial it back 2 steps. You don't really know what's going on until like the 3rd to last move of the game. And then suddenly you're like, oh no, what have I done? So this is, you draw this little pyramid. So it's a little triangular number game. So you draw 6 rows. So you've got 21 little spots. And then you just take turns. You need 2 colors actually. And you take turns placing your numbers. So, brown goes in places of 1, green in places of 1. You keep going, place your twos, place your threes, place your fours, up until your tens. And then, right, the sixth triangular number is 21, not 20. So there is one spot left unfilled, and that is the black hole. And it destroys the surrounding numbers. They are sucked into its orbit. And so what you want to do, sorry, I blacked them out so they're hard to see who won, but you want to lose the minimum amount of material to the black hole. So green has played this very well. They only lose their smallest number, whereas brown is quite exposed to the gaping maw of the black hole, one's losing 13, and so green is triumphant. And that's black hole. It's very, very quick. You guys want to try that one? Yeah. Oh, it sounds like are we done or are we
Like group 7, 8, 9.
Yeah, 7.
Yeah. Oh, it's right. Yeah. Yeah. Thank you a lot.
Thoughts or questions on that game? Yeah, this is one where I have very little strategic intuition about this game. I feel like this is one of these ones where you move 8 or 9. Now I can start to like, okay, well, I can exhaustively search my possible moves and see that they're all terrible. But like move 4 when I could have done something to better my future, I don't know what to do. Like I can't quite see the board that well that early. It wouldn't surprise me if there is some analysis to be done here though, right? The classic dots and boxes game, which you've probably seen, is another one where like in my playing of that game, it is pretty haphazard until suddenly it's like, okay, I gotta start making boxes. But Burlekamp has written a whole book on this, actually, right? Burlekamp passed away a few years while writing this book. We got a whole book on dots and boxes, and it's not a solved game, but there's some pretty general theorems essentially that you can prove about good dots and boxes play. Anyway, if you want to prove some theorems about this, please tell me before you publish them. I'd like to know how to win this. So this one, this one, right, I mentioned at the beginning that like I originally thought of math games just kind of like fun little time fillers, but you know, I've come to see them as deeper somehow. This one actually I kind of feel like is a fun little time filler. Yeah, I don't know. If I use this in a class, it's because I got one little fun time filler, which is fine. Okay, last game. We might not get through all the rounds I have in my slides, but that's fine. The game is called Outrageous. Now, right, sometimes I'm in a room where there's like 1 or 2 people who do know the answer to this one. Often people don't. Okay, well, there we go. So that's good because it's just my practice question. So 1 or 2 people in a well-educated room will know the answer. Many won't though. So the idea of this game is it's a trivia game. Every question is numerical. You can play like as a board game night kind of game. Everybody takes 10 minutes beforehand, like goes on their phone and finds you a numerical question to ask. And then you don't guess a number. The point is not to guess, to make a point estimate. We're not just flinging haphazard point estimates around. We're thinking like statisticians, and we're giving confidence intervals. And so you're sort of going for like your 80% confidence interval usually in this game. And so if you don't know very much about the question, your interval will be very wide. So that first person is not very knowledgeable about countries. They're like, countries in Africa, there's like Egypt, probably some others, I think. At least 10. And then how many countries? Like it can't be more than 90. Okay, so that's a very wide range. Third person there feels very knowledgeable about it, as you may have guessed. They've got it wrong. Right, in particular, South Sudan is the most recent country they recognized in Africa, and that was 15 years ago or so. So if this person went to middle school when I did, they would have learned that there were 53 countries in Africa. So their information is out of date. Anyway, everybody guesses, and then you so it's 54 as we know, and here's how the scoring works. You play against usually like a table of like a group of 4 is kind of perfect for this game. You can do 3 or 5. And you get 1 point per opponent that you defeat. So you defeat an opponent one of 2 ways, right? Either you got it and they missed it, right? Clearly you won. So they said 52 to 53. You said 0 to 1,000,000. That was honestly a pretty silly thing to say about countries in Africa, but like there exists a country in Africa, million, but whatever, 0 to 1,000,000, you won the point. Or to make sure not everybody goes 0 to 1,000,000, if both ranges are valid and someone says 0 to 1,000,000, but somebody else says 1 to 10,000, they are more knowledgeable about this. They gave a narrow range, and so they get a point. So in our little example round, that third person who missed it, they're the only one who missed it. They get no points for the round, and then everybody else gets 1 point for beating them. Right, and then you kind of order them narrowest to widest. So the person with the 10 to 90, they get a point because they did get it right and somebody missed it. If everybody gets it, then the widest range will get nothing. Right, so if that person had said 0 to 1,000,000, they would still score 0 points. And then the best you can do is you get n-1 points because you beat all your opponents. Questions about this? Okay, so look around real quick. Point out like you want like a group of 3 or 4, let's say. Like,
Here's question 1.
if anybody here thinks in metric, I can take out my phone and convert it to metric. I don't know off the top of my head. NBA players.
Okay.
Feet and in Alright. So right down here at the human psyche. So anyway, thank you. I'll show you the answer in a second. One mistake I've made in the past when playing this game is I've done like 5 questions and everybody writes down answers, and then we go through the 5 answers, and like half the room goes 0 for 5, half the room gets them all wrong because people are not used to it. I don't think this would happen in here. You were all very sophisticated mathematical thinkers and used to couching your understanding, knowing what you don't know. But we are atypical human beings in that respect. Most people will just like give a really narrow range and miss it. So anyway, this one we'll go question answer. I think maybe we'll do 3 questions. I have more than that myself, but I think we'll do 3. You guys ready for the answer? Can I get a quick drum roll? 6'6".
Yeah.
Yeah, scoring questions. If you had it, I think, let's call these closed intervals, unlike in a typical confidence interval in statistics, which I think would conceptually be an open interval. So closed interval. So if you had 6 as a boundary point, count it. If two people tie, I usually say split that point in half. So they each get half. Question 2, how old am I? So, all right, we got your graph. This one should take complex population. If you like, yeah, 0 to a million. 37. Hi, I'm Andrew here. I'm gonna have you. Yeah. I think I've got 3 more in the slide. We're just gonna do 1 more. So let's do, you want to do all 3 questions?
Yes.
Yes. We'll do, you can always, you can play on your own time, right? You can always do your like couple of questions and challenge those people around you. Don't explain the game to them, just challenge them. So this one, do you want to do this question or do you want to go to the next one? Did you want that or next question? Are we happy with that? Let's go next question. I'm just gonna spoil this one for you. Ready? Do you have this one or you want to go to the next one? The next one. It's 3 4 3. Yeah, wait, 1 3. 3.1. Sorry, not the line. Okay. How many standard wins do you have? Well, this will be our final question.
They're going to for sure.
Yeah, Going to Bed book is one of Sam Wayne's titles. I won't say whether we have it, but not the problem. Sam Wayne is a writer of small, they're mostly like little this-sized cardboard type of work. Targeted at actually, the other one's two.
Popular entertainment. Can I get a drum roll, please? All right, okay, let's take that one. So real quick, let me jump in. I just want to say one last story. Raise your hand if you know the story of the 1994 Caribbean Cup. Okay, oh, I can't let you leave without telling you the story of the Caribbean Cup. So one question is like these games, they're mathy, right? They're like connected to mathematics. One can think mathematically about them. But someone asked me early when I was working on this book, like, what makes these math games, right? And like one answer is I don't know. So somebody with a math degree is talking about them, so they must be math games. Another one is that, and this is the way I like to think of it, is like, what is math? It's logical play within a space of rules, right? You set up rules, and then within those rules, you just create a little building of logic, and you play inside that building, and you see what you can do. One of the greatest examples of this comes not from mathematics, but from soccer. The 1994 Caribbean Cup. Greatest thing possibly ever to happen on this planet. It's a cool planet. I really like this planet. So this was group play. And let's see, you can see the games that happened, and the current game that was going on was Barbados versus Grenada. And so the way this works, only one of these teams is going to emerge from group play. And so if Barbados wins, let's see, Grenada wins, they're just in because they've won both games. If Barbados wins, everybody's got one win and one loss, and we go to tiebreakers. Tiebreakers goal differential. So take how many goals you scored in the 3 games, subtract how many goals you gave up, and that's the goal differential. So in this situation, imagine the game ends like this. Barbados 2, Grenada 1. Barbados now, their goal differential is going to go up to 0. Grenada's will go down to +1. So Grenada advances. So this is a bad outcome for Barbados, despite the fact they're winning the game. So you think, okay, this is the score in the final minutes. Right? It's like 5 minutes left in the game. And you think, okay, well, Barbados needs to score another goal. They got to press on offense, right? Pull the keeper up to midfield. But there was one little rule that they had changed for the Caribbean Cup, a rule no one had ever tried before. Because who cares about these tiebreakers? What they did is they wanted to just like make it extra exciting if the game went to overtime. So that you know what, if you score in overtime, we'll count that goal double. Harmless. I don't know, like you're already like, well, how could that matter? Right? It's like if it's in overtime, you want to score. What does it matter if you then give an extra point to the goal? It seems fine. It's like, it's sort of like, what if we take Euclid's fifth postulate and just prove that from the other 4? Right? Just tweak that. Turns out you change this rule. And can you guess what Barbados did in the closing minutes? 1 goal. They said, well, we can just win in overtime. And if we win in overtime, they're like, it's very hard to score a goal right now. There's 4 minutes left in the game. We'll score an own goal. And they did. And suddenly it was 2-2. And Grenada is done. They're like, what? And then they look at the rules. They're like, oh, right. We don't want this to go overtime. So Grenada tries to score an own goal. Barbados has thought of this and defends Grenada's goal. At which point Grenada, very confused, like, but we could just score a regular goal, that's fine too. And they try to score the other end. Barbados defends both ends of the game. The last 3 minutes of the game, they're scrambling. Barbados defending both ends. Grenada just trying to score somewhere. They don't really care. Just either end. They're unable to do it, and Barbados wins in overtime and advances to the next round of the Caribbean Cup. Which to me is like just one of the most beautiful things that's ever happened. It's like Somebody in an office somewhere was like, oh, change the tiebreakers a little bit. Why not? We'll give a double point for an overtime goal. Everybody likes overtime. And it's like, when I do like overtime, you know what I like even better is utter chaos. And to me, I know these were not literally mathematicians, but that's some of the best mathematical thinking I think you're likely to find. Soccer field. So why do math games matter? On the slide, they teach us new ways to think and indeed new ways to destroy the game of soccer. So thank you for I think that brings us to the people parties or questions. Questions. Yeah, questions, yeah.
So okay, I like the final quote that you ended with, like math games are, what is it?
Yeah, they
Playing
play within
within
the
the
system block rules. Yeah.
So when you're playing games with students in a classroom setting, of course you have rules in the classroom
Yeah,
and like how you run a classroom with like tests and whatnot, what you may do.
yeah.
Has there been anything because of the way that you encourage creativity in the classroom that has stuck with you that a student has tried to pull? That you
Yeah.
let slide or?
Right, do I get like a Barbados student? to
Yes.
come? Yeah, I like to think that I design my incentive systems robustly enough that they don't incentivize the like trying to score on the wrong goal stuff. But certainly with assignments, sometimes, yeah, with an individual assignment, I'm remembering there's one, these were pre-calculus students who just piecewise functions, which I thought of as like, it's like a function. But I'm just telling you what it is. Like, it doesn't seem like very much to me. They're finding it really hard, bright students, and they were just not, piecewise functions were not clicking for them, the notation, something. So it's like, okay, how can I make them care? Not the obvious thing to make 16-year-olds care, but I was like, well, taxes. Like, if you want to think about taxes, it's basically a piecewise defined function. And so I was sort of just like ad-libbing one day and realized they really didn't understand how tax brackets work, which led to my discovery that indeed no one understands how tax brackets work. Everyone thinks that it's like the marginal tax rate is applied to all of your income as opposed to just the marginal income. Anyway, so we wound up doing a project where they had to create their own income tax system. And I was thinking they'd come up with some kind of like variation on the US system. And one kid who just liked to troll me, he made the margin, it was not only regressive, I think the marginal tax on low incomes was over 100%. It's like, if you're gonna make money, you better make a lot of money. You're only gonna make 20,000 this year? No, I'm taking 22. Which was like ridiculous, obviously, but also the math was very well done. So it certainly didn't take off any points for him having insane politics. So that would be an example, I think, of being designing, but that's also, to some extent, I'm happy to have that play in the space. Yes.
Classroom, what was your favorite way to like incorporate games? Did you mostly use them as like time fillers? Were you able to weave them into your lessons?
Yeah, some of them. So the ones I do in the book are specifically non-curricular. I sort of like didn't want to do, because there's a lot of games out there that can be fun as a way of practice, but like, it's polynomial dominoes. It's like it's like not quite as fun as messing with people. So these days, actually, I'm teaching a course. It's called Liberal Arts Math. Although it's not particularly liberal artsy, it's much more practical. And the way it's structured is the students mostly work full time. So it's like basically 3 hours once a week, which like is too much. So we play half-hour games each day. I don't really like it builds culture, which is good. It exposes me different sides of their thinking, which can be interesting. And then and sometimes there are connections you can kind of weave back and get. Yeah. So I think there's benefits. It's not, if it wasn't a 3-hour class, I might not be giving a half hour to playing games, but given that it's such a long stretch, I find them useful there. And like outrageous, I think is genuinely a useful one for me. Yeah, because thinking about interval-based thinking. Other questions?
You don't mind?
Yeah,
So
yeah.
kind of piggybacking off that, if you had the choice, or if you had the option to sort of say, I'm gonna just pick some random, pre-calculus is a requirement, right? Would you rather a student take pre-calculus as their only math class they're ever gonna take, or something that's game-based, like what you have?
Oh, sure. Yeah.
As the only math class they're gonna take?
Yeah. This is tough. I think a lot about having taught sort of all through that stretch of the curriculum. I think a lot about like the algebra, sequence algebra, kind of through calculus. It makes for a pretty lousy terminal math experience, I think. So if you know you're not going to be taking more math, ending with pre-calculus is a weird
Sorry. What was the final thing you did? I did the parade of the creature. Okay, even calculus is sort of a weird terminal math class for a lot of purposes. Because it's it's a gateway in so many disciplines and it's a tool for so many disciplines, but if it's the like you're not going to be using it for those disciplines, it's a little weird. That said, I mean, part of the challenge with education is you never know if it really is someone's last math class or where they're headed. And so, yeah, I don't know. I don't have a blanket prescription for what a terminal math class should be. Although the one I teach now, this liberal arts math class, is like very hands-on. It's all in spreadsheets. We can do virtually nothing algebraic, and it's like, I mean, there's sort of algebraic thinking, and can you write a spreadsheet formula that that you can drag across and does the right thing you want it to do. But mostly it's much more practical. Other questions? Cool. And I'll be around. I'll be around during pizza in the morning. I'll be yammering again. We'll chat more.